show you a first example of a so-called linked list. The idea behind the linked list is to create a list of elements of a type of a structure, but rather than putting them in an array, they live in different places in memory, and each element of the list knows the location of where the next element of the list is stored and keeps that location. So you can move from one element of the list to the next via those location addresses that are stored in the elements. Let's look at an example. Let's again look at the example where we store x and y coordinates of a point in a structure. So again, let's call the structure point, as we did before. It's going to be a little different though than before. We have an x coordinate, let's say that's an integer again. We also have a y coordinate. But as I said, we also want to store the address of the subsequent element of the list. And what is that address? It's a pointer to a struct point. And so that will be written like this, and let's call that element next. So next is another member of the structure struct point, and it's the address of another struct point. So now that we have this, we can manually create a list of points. And I'm going to do that entirely manually by simply declaring 3 points here. Struct point, pt1 is my first point, and I'm going to initialize it with some coordinates so I don't have to type them in as the user later on. Let's say the coordinates are 1 and 2, and for now I don't know what the address of the next element is. I'm going to simply put a null in there. Null is in the null pointer. Null means I just simply don't know what the address is. And then I'm going to create a few more points, 2 more points. Let's see if we can copy and paste this. Point 2, let's come up with some new coordinates. How about -2 and 3? And again, I don't know what the next point is yet. And point 3, 5, and how about -4 and null. So now I have 3 points, and let's suppose I want to link those together. Later on, we won't be declaring elements of our linked list like this as direct variables, but rather we will be creating them dynamically during the running of the program using malloc. But as our first example, I simply declare them as variables. And what I want to do now is I want to store in this first null element of pt1 the address of pt2. And I want to store in the next element of pt2 the address of pt3. And that'll link these 3 points together as a so-called linked list. In a linked list, you tend to keep track of where the list starts. So it's customary to have a pointer, struct point pointer, to the start of the list. And also a pointer is in general, a general pointer that helps us move through the list. So these 2 pointers are pretty customary. And where does my list start? Well, the start of my list is the address of pt1. That's how I want my list to start. And what is pt1 next? So the next component of pt1. First of all, how do I address that? pt1 is a structure, so pt1 dot next is that element where the address of pt2 is to be stored. So I want the address of pt2 there. And in pt2, I want its next member to store the address of pt3. So now I have linked together these 3 elements. These 3 instructions have linked together these 3 points that are declared above into a linked list. Let's compile and run this to see what happens in memory. So first, I'm declaring my structure point pt1. There it is. It has an x coordinate of 1, a y coordinate of 2, and so far a null sitting, a 0 sitting in the next component. Then there's pt2. It has an x component of -2, y component of 3, and next of 0, because I haven't assigned another value yet. And there's pt3. And move it over a little bit so you can see pt3. All right. Then I declare some more pointers that I'm not even using right now. Next, I give start the value of the address of PT1. Where does PT1 start? It starts at FFF4. So let's move over and watch start as I execute this next instruction. And FFF4 appears in start. Next, I say PT1.next should be the address of PT2. So I'm going to move over the memory strip. PT1.next is all the way to the right of the memory strip. Currently it has all zeros in it. I'm going to assign it the address of PT2. The address of PT2 is FFE8. So I expect FFE8 to appear in PT1.next, and so it did. So PT1 now stores as one of its members the address of PT2. Next, I'm going to put the address of PT3 into PT2.next. The address of PT3 is FFDC. Now watch what happens to PT2.next as I execute this instruction. FFDC appeared in PT2.next. So now these 3 points, PT1, PT2, and PT3, are kind of linked together because each one stores the address of the next one in its member next. This will allow us to move from one point to the next by only knowing where the first point is located in memory. And so let's do that now. We will use the pointer PTR as the pointer that helps us to move through the list. So initially we want PTR to point to the beginning of the list, and we call that start. And now we can move through the list, and as long as we're not pointing at null, we know we are looking at a member of the list whose X and Y component we might want to print. So while this PTR is not equal to the null pointer, I can, for example, print out %D and %B. I just want to print the X and Y components. How do I print those? I want to print the X and Y components of the point that PTR is pointing to. So PTR needs to be dereferenced first, and then I need to go to the X component. The arrow does that for us. It dereferences and then moves to the X component. Similarly, PTR arrow Y gets me the Y component of the point that PTR is pointing to. I don't need to bother with the next component. That's just to move on to the next one, and I'm going to print that out. Rather, after I've printed a point, then I want PTR to move on to point to the next point. So we need to update PTR as the next component of the current PTR. So the new PTR is the next component of the current PTR. The next component is the next point. So originally PTR points to PT1, then we would print out the components of PT1, the X and the Y coordinates, and then I go to PTR next, the next component. Well, that's the address of PT2. So PTR is then updated with the address of PT2, and we start from the beginning and print out PT2's X and Y component, and then move on to PTR. So this will allow us to move through the linked list and print out all the individual components. And that's all there is to this. Let's take a look, compile and run this program. So the beginning we already talked about. So I declare my 3 points, and I link them together with these 3 commands. So PT1 now stores the address of PT2, PT2 stores the address of PT3, start stores the address of PT1. And now I have the commands PTR equals start. So I'm going to move the memory strip to the left to take a look. PTR has the value FFF4, it's the same as the value of start, and FFF4 is the address of PT1. Okay, so it's not the null pointer, PTR is not null, and so that means there is something to be printed. So the next line reads the X component of what PTR is pointing to, and the Y component, so that's the 1 and the 2, PT1.x and PT1.y. Next, PTR is updated. Currently, PTR has the address FFF4, but it's going to be updated with what's stored in PT1.next. So let's watch what that is. PT1.next is FFE8, and PTR now has that value FFE8. and that is the address of where PT2 is stored. So I re-enter this while loop because PTR is not the null pointer, and print the x and the y components of PT2 because that's what PTR is now pointing to. So -2 and 3 are printed, and then PTR is updated again with the value that's stored in the next component of what PTR is pointing to. The next component is FFDC. So PTR is updated. Let's go take a look. And indeed, it has the value FFDC, which is the address of PT3. It's still not the null pointer, and so we enter the while loop again. We print the x and y component of the point that PTR is now pointing to, which is 5 and -4. PTR is updated. What is it updated with? It's updated with the next component of what it's currently pointing at. It's pointing at PT3. Its next component is the null pointer. So PTR is updated with a null pointer. It is now the null pointer, and so the condition of the while loop is no longer satisfied. We exit the while loop, and the program terminates. So this is a hand-built linked list. Later on, we won't build linked lists by hand at all. We will build them on the fly during a program, but it's an instructional example to look at it this way. Again, play around with this linked list, build your own, and watch in memory what happens.